Hello, I'm Mr. Howard. In this video we're going to look at absolute value reflections. Okay, in Algebra 2 you looked at the absolute value function, and that had a shape, this V shape like this. And a table of that would look something like this. If you just had the absolute value of x, so that this would be the table for it. So if your x was -2, then your output, your y, would just be 2. If your input, your x, was -1, it would output a +1. If you had 0, then of course it would still put out a 0. If you had a +1, it also would output a +1. +2 outputs a +2. So even for negative x values like -1 and -2, you still have a positive y value over here. So that's why you get this V shape. So you have seen that before in Algebra 2. So here in pre-calculus, we're going to look at absolute value in a different way by applying these absolute value reflections to various functions. Okay, so we're going to first start by looking at an f of x, so some function. Then we will apply the absolute value of the whole thing, absolute value of f of x, and then we will apply the f of the absolute value of x only. Okay, so when we take the absolute value of f of x, so this one right here, the whole thing, we are going to reflect all of the negative y, so any negative y parts of the original f of x will be reflected over the x-axis. So you will not have anything below the x-axis. All your negative y's will be gone. And we have a description here in our shift chart that is available in the pre-calculus resources page, and this describes it. It's a little wordy, and I think it's easier just to look at some examples to help you understand how it's going to work. The other one, this one right here, the f of absolute value of x only, so this part is going to be symmetrical about the y-axis. So we are basically going to take all of the positive x values, so everything to the right of the y-axis, and reflect that over the y-axis. Anything to the left of the y-axis in the original f of x is just removed. Okay, so this is talking about quadrants. So quadrants 1 and 4. So remember, if we have our quadrants, this is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So these two, 1 and 4, stay and are actually reflected, and these two, 2 and 3, are removed. That's what this is talking about on your shift chart. Okay, but again, I think it'll make more sense here in a minute when we actually look at some examples. So let's look at an imaginary f of x function, just something that we make up and apply those transformations. So we're going to do that next. Alright, so here we have just a basic relation, this is a function that I have sketched in here and just made 3 copies of it. So if this is the original, the first thing we're going to do is apply this absolute value of f of x, absolute value of this whole f of x function. Okay, when we do that, look at it this way. Remember, f of x is like your y. When we look at this, our x is here, but f of x is the output, the whole function. Okay, so when we have that, we are going to take all of the positive y values, so anything above the x-axis is going to stay, but everything below the x-axis, so this part right here, is going to be actually reflected over the x-axis. So it's going to look like, in green here, it's going to look like something like that. You still have all of these parts, so I'm just going to trace over this like this. So in green here we have the absolute value of f of x, so it would look something like this. Okay, so this part down here gets reflected, and it is then actually removed, so it's not going to be there anymore. So I'm going to come in here and erase that. Okay, so that's what the absolute value of f of x reflection looks like if this is your original. We have taken this part here, everything below the x-axis, all the negative y's, and reflected them over the x-axis, and all the remaining part below the x-axis is erased. Okay, so that's what this would look like. Alright, now let's look at this one over here. Alright, so we have, this time we have f of the absolute value of x only. Okay, so that rule said that we take all of the positive x values, so everything to the right of the y-axis, and that is going to stay. So I'm going to trace over this in green because this is going to be our what we're going to end with. Okay, so all of that's going to stay. All right, and then this part, the green part, is actually going to be reflected over the y-axis, so that now this thing becomes symmetrical about the y-axis. That's supposed to be symmetrical. My drawing may not be perfect. And then all of this original part that was to the left of the y-axis gets removed. It gets erased. And then you stop and you end with this. So we take the positive parts, this part here, the positive parts of to the right of the y-axis, so all the positive x's, and that portion of the graph is reflected over, and all of this stuff over here gets erased. Okay, so that is those are the basics of what's happening. Now let's look at an actual example, and I think that will help also set this in your mind as far as what is going on here. It's really not that complicated, especially after you apply it a time or two. Alright, so let's look at an actual example. Alright, here we have example 1, and we have the function f of x equals negative x plus 3 quantity squared plus 4. So this is a parabola that is flipped over the x-axis, so it's opening downward, and it's been moved left 3 and up 4. So the vertex is at negative 3, 4. So I've gone ahead and sketched this in here, and it would have a y-intercept here at negative 5 if you work that out or put it in your calculator. So this is our f of x that we're starting with, and now we're going to apply the absolute value of f of x reflection and the f of absolute value of x reflection, okay, to this original graph and talk about what's going to happen to it. Okay, so let's take this thing and let's start with this one. So this is our original f of x given to us here, and remember that the absolute value of f of x, the absolute value of the whole thing, we take all of our y's, we view f of x just like y. This is the way we're looking at it. So all of our negative y's need to be reflected over the x-axis. So this part right here gets reflected over the x-axis. So something like this and something like this. Okay, that's not perfect, but that's approximately what it's going to look like. And then all of the positive y values, so all of these stay just as they were. And then the negative y coordinates of the original are actually erased or removed, or they're not there, okay, anymore. So that's gone. So that's what that one would look like. Okay, now let's look at f of absolute value of x only. So there we said that all of the, because we're only talking about the absolute value of x now, just that reflection. So all of the positive x's, so this portion right here, all of this is going to now be reflected over the y-axis, so this thing becomes symmetrical about the y-axis, and all of the original negative x coordinates of the function are actually gone. They are removed, they are erased, however you want to look at it. They're not there anymore. So all of this is now gone. Okay, and only the positive x's from the original are now reflected over the y-axis. So this thing becomes symmetrical about the y-axis. So everything else is gone. Alright, so let's look at how this would look in our graphing calculator real quick. And I think that will help you see the picture. Certainly better than my sketches here. Alright, but in the assignment, this is what you're going to be practicing, is doing the same process to many different functions. Okay, so let's look at our calculator. Alright, so I've gone ahead and put our original function, our original f of x here in y1, negative x plus 3 quantity squared plus 4. So we graph that in a standard graphing window, and we get this approximately what my sketch is here. It has a vertex at negative 3, 4 and a y-intercept at negative 5. So that's our original. Now I'm going to show you how to put this reflection in. So we're going to take the absolute value of the whole thing here. So the way we get the absolute value in our TI graphing calculator is we go to Math, we go over arrow right once to the number menu right here, and we choose option 1 for ABS. That's absolute value. Okay, so we're going to select that, and as long as you have the newer operating system with MathPrint on, it adds your absolute value bars. That's what these are. It adds those in there for you, and you just start typing. So we're going to put this whole thing in there this time. So negative parentheses x plus 3 quantity squared plus 4, all of that, everything is inside the absolute value bars because I'm taking the absolute value of the full f of x function. Alright, so I'm going to go over here now and I'm going to darken the y2 here, which my y2 is this one, the absolute value of f of x reflection, so that we can see that compared to the parent function. So it's going to graph the parent function, or not the parent function, but the original function, this one right here that we started with. It'll graph that, and then it'll graph the f of x reflection a little darker. So let's graph it now. Okay, so there was our original, and then it came in and graphed this reflection. So notice the darker line here is the reflection. You can see here how these negative y coordinates here of the original graph in the thinner line are being reflected over, and they're going on forever. Remember, this parabola drops on to negative infinity here. So now they're going off to positive infinity this way because this portion on down to negative infinity has been reflected over the x-axis and now is going to positive infinity this way. The original graph part, this section, so this section in green here now, is still there as it was before, and this part, all of the negative y coordinates here, are being reflected over the x-axis, and they're now going off to positive infinity. So that's what it looks like. If we turn off, so to turn off a graph that you have in here, you just go right there to that equal. So hit the left arrow so it's flashing on this equal, hit enter so that it's no longer highlighted, and you graph, and now the original's gone. Okay, so now we have this right here. Alright? So, of course, your calculator is not actually erasing these parts. It's actually just performing this operation. It's taking all of the negative y's that were there and they're being reflected. That's the resulting graph. Okay, so now let's look at this part. So I'm going to go in y equals now. I'm going to turn my parent function back on. Not my parent function, the original function back on. I'm going to turn off the y2 this time, and we're going to put this part in y3 now. Okay, so remember, this is f of absolute value of x only. Just the x is going to be inside my absolute value bars. So I'm going to type this all in, only placing the absolute value around the x only. So it's negative parentheses, and now I'm going to put my absolute value bar in, math, over to number, choose the first option, absolute value, put the x in there, and that's it. Now I've got this little arrow here saying that anything I type in here now will still be in the absolute value bar, so I'm going to hit the right arrow to get out of it. So now I've only put my x in the absolute value bars. That's what I wanted for this reflection here. So then it's plus 3 close parentheses quantity squared. So everything looks good so far, and then the plus 4 goes in right there. Okay, so I have negative absolute value of x only plus 3 quantity squared, and then plus 4. Okay, so I'm going to go over here. I'm going to darken this in so that we can see our reflection. It will be darker. So now I'm going to hit graph, and we're going to see what happens. Okay, remember our y2 graph, this one has been turned off, so we're not going to see that one. So I graph it. Here's the original, and here comes the reflection. Okay, just you can barely see it down here, but it's just this little bit. So all of the positive x coordinates of the original that are going like this down and drifting right to negative infinity in the y direction, positive infinity in the x direction, are now being reflected over the y-axis. And all of this stuff right here is gone now. Okay, so if I go up here now and I turn off my original f of x, we're only going to see this part down here. Now if I open my window up and let's say I make a y minimum now like negative 20, so we can see a little bit more of it, just realize that this is going on forever here. Okay, now we can see more of the original graph. Okay, all of the negative x coordinates are gone and the positive x coordinates have been reflected over. Alright, so those are the basics of the absolute value reflections, and now you're going to get to practice this on many other examples. So that's it for this video, and I will see you in the next one.